Hello. In this video, we are going to look at the errors that can occur during the lexical analysis phase and how the lexical analyzer handles these different errors. So, we have already seen that the lexical analyzer is provided with the specifications of the tokens. Okay, which are the tokens of that particular language, and then based on this specification with the input source program, it checks if the input program, the characters in the input program matches the specification. If it matches, it generates the token for it. Okay, now what happens if it cannot determine whether it is a token or not? Say for example, I have this. Okay, I have this statement A f of x, this something. So this is assumed that this is in C. So now here if you look at this statement, then you can look at this identifier or this particular string fi. Now this could be a misspelled if, misspelled if, okay, the programmer has made a spelling mistake, or it can be a variable fi, okay, because it matches this matches the description of the token for a variable. Fi is a valid variable name. Okay, so now because we have seen the entire statement, we have seen this whole statement, so we know that it should have been if. Alright, so it is a spelling mistake. But for the lexical analyzer, it cannot see the rest of the program, rest of the string. So it is just looking ahead for a few characters. So what it will do, it will assume that this fi is a variable name. Okay, and it will create a token for fi, and it will enter fi into the symbol table. But actually this is a syntax error. So the lexical analyzer cannot catch errors like this. So it will hand this over to the syntax analyzer or the parser, to the next phase of compilation, and it is the parser who will detect this error because it will not match with the syntax, the grammatical structure of the sentence. So this type of errors the lexical analyzer cannot detect, or rather if it will leave it to the other phases to handle. In certain other cases, we may have something like this. Suppose I have something like this: a underscore multiply plus dot, okay, a b assigned 25, something like this. Okay, now the lexical analyzer is here. So what will it make out of this? It knows that the specification of the language doesn't say anything about underscore. So underscore is not defined. It is not a special symbol for that particular language. Okay, it does not belong to the alphabet of that language. So can it be something else? So here at this particular point of time, because the lexical analyzer cannot classify this into any of the token groups, so what it will do, it is stuck here. So in such a situation, the simplest recovery strategy that a lexical analyzer can use is something known as panic recovery. So it is known as panic recovery mode. So in panic recovery mode, what it will do, it will keep on scanning and deleting the characters one by one. So it will say delete this, it will delete this, it will delete this, it will delete this. Now at this point it finds A, okay, it can be something, it can be something here. Okay, so it can be a variable. So it will go on deleting the characters from the remaining part of the input until it detects a well-formed token at the beginning of whatever of the input is left. So now it will ignore all these characters and it will take this as an identifier. Okay, so this is known as this type of recovery is known as the panic recovery mode. So as the previous question or as the previous example, the handling of this error will be left to the next phase, that is the parser. The parser will have to say that this is wrong. This is not the only recovery mode. This is the simplest, like I said. So let me just write down. This is the simplest mode. So the other recovery modes, what it will do? Other possible recovery actions, error recovery actions. So the first one is delete one character. Delete not all the remaining characters, one character. So it will delete one character and then check. Okay, so this is not panic, so it is deleting one character, and most of the time this will work. Then insert a missing character into the remaining output. So insert missing character. So suppose I write WHIL. I forget to write E. I want to write a while loop, something like this. So the lexical analyzer will try to input something. It finds a match with WHIL, but then it does not find a E. So it will try to insert one character in the remaining input. Then the third recovery strategy is replace a character by another one. So replace a character by another. So it will replace a character by another. So suppose say WHIL, instead of E I write T. So it will try to replace T by E. Then number 4, transpose adjacent characters. Transpose adjacent characters. Like say for example, again our previous example, this one. So here, so FI was actually a mistake. It should have been IF. So if it will transpose it, it will just exchange the two characters and convert it into an if. It will consider it as an if. So these are different modes in which if a lexical analyzer is stuck, then it will follow some of these recovery techniques in order to recover from the error and proceed. So if there is any error, if it does not match anything, it will follow any of these techniques and leave the rest to the parser to handle. So that's it for error recovery actions.